The mean value theorem. Let f be a function that satisfies the following hypothesis. Number 1, f is continuous on the closed interval AB. F is differentiable on the open interval AB. Then there is a number C in AB such that f prime of C equal f of B minus f of A divided by B minus A, or equivalent. We will multiply both sides by B minus A, then we get this equivalent equation. What we are going to do is we use the Rowland's theorem to prove the mean value theorem. So I copy the Rowland's theorem on the top, and we need to have 1, 2, 3 conditions right here. Then we can have the conclusion. Then there is a number C in open interval AB such that f prime of C equal to 0. So when we have this conclusion, then we will continue to work from that. Okay, so we need to have 1, 2, 3 conditions in Rowland's theorem. Now let's take a look at the graph. Assume that we have a curve y equal f of x, and we pick a 2 points A and B on the curve. Let's connect AB. Then the line AB will be the secant line. To write the equation of this secant line with the point A, passing through a point A, then we have y minus y1, which is f of A, equals slope x minus x1, which is A. And the slope, now we have a 2 point A and B. Then we use algebra. The slope will be f of B minus f of A divided by B minus A. And we want to solve for y. Then we have f of B minus f of A divided by B minus A, x minus A, and then plus f of A both sides. Then we will get plus f of A from the right side of the equation. Okay, so after that, this is the function f of x, right? F of x. And this is the function, the secant line. So this is the function y. And then we want to find the difference between these two functions, which is in the green color. So this is the h of x, okay? So the proof is let h of x be the difference between the function f and the secant line to f on the closed interval AB. So we will do the subtraction. So f of x minus, so this part is the secant line. We just wrote the equation of the secant line if you remember before. So h of x is the difference between the function f and the secant line. Then what do we know about the function h of x is it is continuous, it is differentiable, continuous on closed interval AB, and differentiable on open interval AB. The reason why is that it is the subtraction, right? This is like plus and minus. So they said this is the sum, but this is the difference of the function f and the first degree polynomial. So which are both continuous on closed interval AB and differential on AB. So that means we have the number 1 and number 2 condition in the Rowland's theorem. So now let's look at number 3 if we do have it. So we find f of A, h of A, and h of B. We plug in the A for the function h of x and plug in f of B for the function h of x. What can we see is they both equal to 0. Then we can conclude that h of A equal to h of B. So we have 3 conditions satisfied in the Rowland's theorem. So we can conclude by the Rowland's theorem that there is a number C in open interval AB such that h prime of C equal to 0. But h prime of C is this, right? And this is the same thing as this. So by definition of h prime of C, this is the first derivative of the h of x. And it's the same as f prime of C equal to f of b minus f of a divided by b minus a. So which is what we want to have in the mean value theorem.